Now the next technique which we are going to take is the filtration. So where does this technique is being used? So it is actually used to separate a solid from a liquid. You can say we can use to separate a solid from a liquid, in which the important thing is being that solid should be insoluble. That means we have got a solution in which we have solid and liquid, and you can say the difference between the solute and the solvent is that the solid is insoluble in that given solvent, right? So how we take it? So we are just going to study it. So again we are going to take a beaker in it, you can see a funnel in it. This is a filter paper. We have got another clean beaker. So how we are going to take it? Before I make you understand this diagram, I want you to look at this side so that you should know. I'll take an example and you should this thing be understanding in a better way, right? So I am taking an example of sand and water. So I am taking a beaker, right, which contain water. A known amount of water is there. I am adding sand to it. So we get a sand solution, right? Then what I am doing it, I am just keeping it aside for few minutes. What happens? When we add sand to it, with the help of stirrer, we just stir it. I think it's clear, because when we are adding anything to any substance, we need to stir it so that it gets dissolved. So it is none of our business whether how much it is going to dissolve, but in this case we should know we are trying an effort best to dissolve it, right? So we are just adding water, adding sand to it and just dissolving, you can say stirring it with the help of stirrer. Then I have just kept this mixture aside undisturbed for a few minutes. Then what I get to see that some solid particles, the sand particles being heavier settle down, and this is the water. Then I am carefully I am pouring this liquid. I am taking a funnel, right, in which I have used a filter paper, a conical shaped filter paper I have used, and I am just with the help of beaker, this solution, I am just pouring this solution which has the sand particles as well as this, and we have one more clean beaker which is just kept below the funnel, right. So what is happening? I am just pouring it. So you know what is going to happen. This filter paper has minute pores. So what it is going to do? It will not allow the bigger size particle, that means the sand particles, to pass through, but it will allow the water particles to pass through. So we will be getting water, and the sand is just separated by this pores and it remain behind in the filter paper, right. So this sand is called as the residue and this water is called as the filtrate, because this filtrate will be cleaned from any, you can say, the undissolved solid particles which were earlier present. So this is how we take it, any example, and just explain by the process of filtration. So again I am doing it for you. From this picture you can see that here is a beaker which contains the water, and or you can say any liquid with solid, and the property is that that solid do not has a tendency to get dissolved, right. This is a funnel containing a filter paper, and there is a clean beaker. We are just pouring this solution into it. What it is doing, it is allowing the minor, you can say the smaller particles of liquid to pass through it, and the larger size particle just stays behind it, because they cannot pass through the pores of these pores, the minute pores of the filter paper. So you can say they just stick to it. These blue ones can pass, these are the water molecules, and these black ones cannot pass because they are bigger in size, so they stay behind, right. So we conclude that what was actually happening in it, or what is the principle behind. The principle is that the particles are of different sizes. We know that some are bigger in size, some are smaller in size. So in this case the larger particles of the insoluble solid is present and the smaller particles of the liquid was present in the solution, which these bigger ones get stopped by the pores of the filter paper and the smaller ones just pass through it, right? So that means this filter paper acts as a sieve. It has got pores, so it is allowing some particles to pass through it, but the larger size to do not pass through it. So that means it acts as a sieve, like, so it does not allow the bigger particles to pass through it. Now the question, we'll be discussing one more question. So if I take a same apparatus, right, and I'm making a salt solution. How can I make the salt solution? You know that I can take a beaker, I have water in it, and I've just added a spoon of sugar to salt to it, and with the help of stirrer I've just dissolved it, right? So when I use that mixture or solution and I pass it through the filter paper, what you are going to see? Can the salt particles get separated by this filter paper or not? No, they are not going to separate by the filter paper. The reason being, you know that we have three kinds of solution: true solution, suspension and colloids. Like, so in case of true solution, the solute particle is too small, so that the too small size of the particles, that means the solute particles do not get stopped by this filter paper pores, and it just passes along with the liquid molecules. So that means the principle behind the filtration is that the two criteria which has to be you can say taken into consideration. The first being, the solid which is used should be insoluble in the given liquid. The second one is that the size of the solid particle should be bigger, right, because that means it should not pass through the pores, and if it do not pass through the pores, it is left behind and it is obtained as a residue. So this is how we explain the process of filtration.